So, yeah. Hello everyone. A very good afternoon. I would like to thank you all for joining us today. My name is Aparna Haldar and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass NullCon, an international security conference, training, and exhibition platform. Hardware.io, a hardware security-focused conference, along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have two products in private beta trials, that is Exploitation, a firmware analysis framework, and CloudFuzz, an advanced fuzzing framework. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that also include Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. That was all about Payatu. Today, Amit Kumar, Payatu's security consultant, will deliver a webinar on gaining access to protected components in Android. You can read all about him on this slide. Before I hand it over to Amit, I request you to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We will answer the questions during the intervals. We will be releasing the recording of this webinar on our LinkedIn page. So make sure you are following Payatu. If you are following the page, check the link in the chat box. You will be directed towards Payatu's LinkedIn page. Without further ado, let's get started. Amit, over to you.
So at the starting, let's introduce myself. I am a lead security consultant at mobile in the Payatu labs. I have 3+ years of experience in AppSec community, and I'm a part-time bug bounty hunter, and I love to find bugs in Android and web application and some of source code. In free time, I love to learn something new every day. So in this workshop, here are some topics. Like first one is Android app components. In this, we will discuss about some basics component and their configurations and how we abuse this. And next is exploring the intent. So in this, we will discuss about the intents and different type of intents and how we use in the real world applications. And third one is getting hands dirty with intent attack vectors. So in this, basically, we will discuss about the intent attack vectors, like from intent misconfigurations, which attacks can be exploited in the real world application. So at the last, we will see a real example of accessing protected content provider by abusing intent misconfiguration. And at the end, we will discuss about the security log, how to defend against these attacks.
Your screen is frozen. Can you please reshare your screen again?
Yeah, is it okay now?
Yes,
So let's start the session. So basically, we will discuss about first like Android app components. So what is components? Basically, we can say that component are building block of an Android application. So without components, there is no any Android application. Components means like activities, services, receivers, broadcast, web view, declink, like that are the application components. So application components are basically building block of an Android application, and each component is an entry point through which the system or a user can enter your app. So what are the main components? Like there are 4 application main components. Yeah, 1 minute. Yeah, sorry guys. So there are four application main components. Yeah, first is activity, second is service, and third is broadcast receiver, and fourth is content provider. So basically, what is activity? Activity, basically, we can say that at that part we can see in the end application, like when we open, for example, when we open any application in the Android phones, so that the UI screen. So the UI screen is called activity, means which we can see that is activity in Android application. And second is our services. So what is services? Services, basically we can say that like the application components that run in the background without any UI, like in background like downloading some applications, downloading some music. So that is services. So what is broadcast receiver? Broadcast receiver means which a component which allows you to send or receive Android system or application events. For an example, there is a two men, one in the room and one is outside the room. So one man in the room and one man outside the room. So when one man in the room says something, so that is the broadcast sender, and other man listen and perform any action like unlock the door. So that is the receiver, other person. And what perform he action? That performed an action though receiving the broadcast. So that is broadcast receiver. So what is content provider? Content provider is basically which store and share data from one application to other if required, like our contact list in the node form. So let's exploring the intent. So basically, what is intent in the Android app? Intent are object of Android.content.intent class. And what is the use of intent? Basically, as you see in the real world, there is a huge use of intent in the end application. So what is the use of intent? Basically, intent facilitates communication between components, like in between activities and services. So it provides communication. So there is some examples like intent is used to take the user to another screen, like another activity within your application. Take the user to a particular URL within the Android web browser, means that like deep link, as you heard about it. And another is take the user to camera to have it take them a picture. So there is some usage, basic use of intent that we use in the our real life. So here is the some intent flow diagram. Like with the intent, we can start another activity. With the intent, we can receive the web view link. So all the actions performed in the end application that is based on the intent, like moving from one activity to another, starting the services, receiving the intent, receiving the broadcast receiver. So all totally depend on the intent. So there is a three fundamental use cases of intent. So first one is starting an activity, means when we open any activity, so that is called starting an activity, starting a service and delivering a broadcast. So there are three main basic components in of intent. So there are two types of intent. One is explicit and another one is implicit. So let's see what their uses and their misconfiguration. So first one is explicit intent. So what is explicit intent? Basically, in explicit intent, if the components are specified as a particular component or service in your app, what is mean? It means when we use a specific component, like in the example, like we are moving to one activity to another activity, like second activity dot class. So that is called explicit intent. Means in explicit intent, we have to include some components, fixed components, like from which to where places, like one activity to another activity. Means we have to configure second activity name, yeah, second service name. So that is called explicit intent. So other one is implicit intent. In implicit intent, there is no any component is specified. So how it works? when we implement implicit intent in the Android application, then Android will determine, means operating system will determine an appropriate activity or any appropriate component to handle that intent. So here in the diagram example, we created a new intent, we setting an action, and we setting some data, https bing.com, for example, and we're starting that activity. So what it means? So whenever application run, then operating system check that which action is defined for which activity. Means operating system will search that action in all application and manifest file, and if the action is okay, then it will start that activity. So that is called implicit intent, means there is no any component is specified in the implicit intent. So here is some memes. So what the heck in these intent types? So basically in this webinar, we will deal with the only implicit intent misconfiguration. So what type of attacks in the intent misconfiguration? When the intent data is not filtered, in the application, then it leads to some serious attacks. Yeah, that leads to intent redirection, intent spoofing, and intent interception. So with abusing of real world exploitation of these attacks, we can lead to access non-exploited component. Means non-exploited components means the components that are set exploited false. As you know already, if any component exported false in another application, we cannot directly access to that components, whether it is a service, whether it is a receiver, yeah, anything else. We cannot directly access that components. So with the use of these attacks, we are able to access the non-exploited components, like accessing content providers protected, like accessing internal files, stealing internal files of that application. So let's hence dirty with the intent attack vectors. So let's move to the first one, intent redirection. So basically with the name means intent redirection means we are redirecting the intent to another intent. Means we are redirecting to the intent to one component to another component. The another component is not exported. So what is the exact mean of intent redirection? So in the application, developers implement some embedded intents. Some embedded, like in the screenshot, it is showing that get partial extra hello. What it means? It means the application accepting serialized object with the name of hello object. So let's move back. What is the embedding intents? Yeah, embedding intents is another intents allows developer to create proxy components and components taking the bundled intent and passing to a method like start activity to launch another component. Here means another activity in that app. So when it happens, yes, same thing. When the developer doesn't filter the intent data, so at that time, the intent detection happens. So here is some example. Like in this, we are getting intent, initializing intent, setting the action, and after setting the action, we are simply accepting the parsable serialized object with the hello object and starting that activity. So here is the exploitation of intent action. So basically in this diagram, main activity 3 is non-exported simply, and wave activity is exported. So we can access the main activity 3 with the exploit of intent reduction. I will demonstrate the practical. So let's demonstrate the practical. Yeah, 1 minute. Yeah, I pasted a link to the chat. Yeah, please open the link and download the apps. Okay, so let's demonstrate. So here is our Android manifest file of that application. So in that application, the main activity 3 is exported false, means we cannot access directly the main activity 3 in the end application. So let's access with the using of intent redaction. So there is a main activity 3 is non-exported. So here is a web activity that is defaultly exported with the help of that intent filter. So here is the code of web activity. So what is the code? Like we are setting an action form.example.intent button, and we are accepting the partialist data, serialized data with the hello name object. And if we get that data, then we are starting that activity. So we can include, we can send any object, like we can send 2 object embedded in that application to abuse the intent redaction. So how the intent redaction exploit works? So let's it's taking some time. Okay, so till the project build, let's in the exploit, how the exploit works. So in this exploit, we are creating intent object with the hello name. We are simply setting the class name, like which class name? It is the package name of that vulnerable application. And second is the non-exported activity. It can be anything. It can be content provider, or it can be any service. So here is in which we are setting the simple class name, main activity 3, that is non-exported. And again, we are creating a new intent with the name exploit. So, and in the exploit name, we are setting the same package name and the other class name that is non-exported. So that is not, let's see, main activity 3 is not exported and web activity is exported. So here we are providing web activity, exported activity, and what happens here? All things going to happen here. So in this place, what we are doing in this place, we are setting some extra data, put extra with the object name hello, and we are sending a serialized object to that application. When the application, when the exploit application gives input to that serialized object, then it can access the protected component, like protected activity. Yeah, wait a second. I'm installing the app. Okay, so it is the vulnerable Android application that we are exploiting. So in the manifest file, the main activity 3 is non-exported. Only we are opening that. We can only open the export components. Like here in export activities, web activity, the launcher activity, main activity. So defaultly the main activity launcher activity is open. So we cannot access directly main activity 3. So let's access with the exploit. So here is our exploit code. Let's run this. Yeah, while I'm checking the logs, application crash. Just a moment. So it might be issue from my side. So wait a minute. Let's solve this issue. What's happening? So here showing we are able to access the main activity 3 in the vulnerable end application. So let's check again. So we are able to access the main activity 3 that is not exported. So what the code of main activity 3? We are simply creating a toast. We are creating a toast of in the main activity like thread activity that we are showing in the exploit. So with the intent redaction, we can access the protected component if the intent data is not filtered. So let's move to another one. So in this webinar, we will discuss some interesting facts. Only one API of end application, not the whole coverage of the real exploitation. Only one real exploitation in this webinar. So before moving to further, we will learn about the interesting Android API start activity for result. So there is an Android API start activity for result. So what is start activity for result? If the developer wants to receive a result from that activity, when it finishes, it calls the start activity for result, and that activity receives the result as a separate object in your activity on activity result callback. So, for example, click the picture and return to the parent activity. Clicking the picture from another activity and return to the parent activity. So it means activity A calls the start activity for result. For the activity B returns the result code and intent data to the activity A. And keep in mind, any activity A calls the set result defined by activity B, then B returns the data only to the activity B. It means when a activity, for example, when a main activity calls the start activity for result, and in start activity for result, set result is defined in the ABC activity. So after finishing the set result code, it returns to the parent activity. Means whoever application calls that set result activity, then the set result activity will return back all the intent data and the result code to the whoever called the data activity. So there are two methods for initializing intents. As you see in the some application, they are using a developers using new intent and some application using get intent. So what is the use and what is the difference between these two intent initialization? So in both of the intent initialization steps, both can give the same result. But in context of an activity, get activity will return the intent. Get activity will return the intent and also initialize the intent, both things. And in the new activity, simply initialize the intent object. It not return anything. So here is the workflow of start activity for result API in the application. So here is our main activity. Main activity start the start activity for result. And the result code is defined in the activity 2. So start activity for result in main activity, waiting for the result from activity 2. And after setting the result in activity 2, it returns back to the main activity. So it is the workflow start activity for result API in Android application. So what the heck in that things? Let's suppose there are two activities. One is set result activity and another one is main activity. Main activity, in main activity, we are setting the start activity for result. And the set result activity is ABC. So if the set result returning activity, if the result returning activity is exported, means if the result returning activity means in an activity in which set result is defined, that activity is exported, then we can call that activity. As we know, if any component is exported, then we can launch the component directly. So as you know already, the set result method return result to the originating activity. If the set result defined activity is exported, then a malware application can intercept and spoof the intent and send arbitrary intent and also steal or access the application private data. So let's discuss about intent interception and intent spoofing. So what is intent interception? So intent interception involves a malicious application receiving an intent that was not intended for it. What it means? Like you are heard about the deep link hijacking. Deep link hijacking. We can receive the any application intent if the deep link is not properly configured. So that is called intent interception. Means we are receiving another application intent data. We are just receiving the another application intent data that the application sending. So that is called intent interception. So what is intent spoofing? We can say that in intent spoofing, a malicious application can send arbitrary data to that application that includes undesired behavior by forging an intent. So what it means? Means we can send any intent, any arbitrary intent to the application. So that is intent spoofing. Means we are spoofing that intent. Okay, so here is the same method. So if we are initializing the intent with the new intent, then we can only intercept the intent. We can't access any other components because in this case, the application not receiving the attacker or any other application intent data. So keep in mind, if any application, if new intent is initialized, then we can only intercept the intent, not perform the intent spoofing. And in another case, if get intent is used to initialize the intent, so in this case, we can intercept and also spoof that intent. And by spoofing that intent, we can access application protected component because get intent returns the intent that was originally sent to that activity. Okay, let's take an example, practical demonstration. Yeah, 1 minute. So here is an example. So let's see the manifest file. So in the manifest file, the main activity is exported. So what is main activity? In main activity 3, there is a set result it defined. And who was the set result in that main activity 3? So main activity is responsible for starting that main activity 3 with the start activity for result. So what it happens here? We are just creating a new intent with the main activity, and another activity is main activity 3 and start activity for result. We are simply sending the intent object and with the request code 1. So what it happens here in the real world, like the main activity is waiting for the result from the main activity 3 in which the set result is defined. So when the main activity finishes, the result code and the intent data is sent to the originating activity. So here the originating activity is main activity job. Okay, so let's move towards the exploit part. Okay, so here is an exploit part. So how the exploit works and intercepting that intent data of that vulnerable application. So here is simply we creating an intent. We are setting the class name. Which class name? Class name in that set result is defined. Here in main activity 3, set result is defined. So in main activity 3, here is the set result defined. So we can call directly. Okay. And after it, we are putting some intent extra like testing and interception for some testing purpose. And after it, we are start activity for calling the start activity for result API. So here is the main case. When the application, the exploit application run that start activity for result, what it happens? It goes to that activity, vulnerable Android application activity. Like in this, the vulnerable Android application activity is main activity 3. So the exploit application goes to this. And as you know, as we discussed already, when the set result method is finished, then it returns to the originating activity. So in our case, the exploit activity means the exploit application main activity is the originating activity. So all the intent data and result code is sent to the our exploit application instead of the original application main activity, because who calls it? Our exploit application calls the set result activity of vulnerable application. So all the intent data and result goes to here in our exploit application. So let's take an practical. So first, let's intercept the intent data. Okay, so let's open run the vulnerable application. Okay, now we run our exploit application. So as for demonstration purpose, we are just initializing the log. We are printing the value is log. So what we are getting, from where we are getting the message value? We are getting the message value from the vulnerable end application. So as same like if when we use get intent, in the case of new intent, then we can send an arbitrary intent to that vulnerable application. So that is the intent spoofing. So let's move to the another part. So we will see on the one use case to exploit the intent attack vectors, because the limitation of some time in the webinar. So after this webinar, I will write a blog of another 4 or 5 approaches of exploitation of intent attack vectors to access content provider, file providers, receiver services. So in this webinar, we will discuss about the only one use case, access protected content provider. So before exploiting the protected content provider, we will understand the content provider and their main components. So content providers are important components of an Android. They handle the access to the central repository and supply data from one application to another on request. Like for example, WhatsApp. When we try to access a context list of WhatsApp, we have to provide a permission. So that content URI permission is given to that WhatsApp. So by the content URI, WhatsApp is able to receive, access all the content in their application. In Android, content providers are to store data applications in one page and make it reliable to different applications whenever it means. If we store some data in our end application, with the help of content provider, we can share that data to another application. We use content provider to allow other applications to access data with some specific requirements. So here is some basic configuration of how we configure the content provider. So there is some main components in content provider. So first is authority. So what is authority? Like in the real world, we can say that authority is a domain name. What's our domain? httpc abc.com. So abc.com is a domain name. So that is our domain name. You can say authority is the domain name of the content provider. And the second is grant URI permission. So what is grant URI permission? Grant URI permission means we can access the content provider URI. Means content provider is a all total domain name. It's a schema. So here is a schema content underscore slash slash and the content provider name. So content provider, we can say that a URL. And grant URI permission means we can grant URI permission permits to access the content provider, that URL. So, okay, so let's move to the access protected content provider. So here is the reload application Android manifest file. And let's have a look at highlighted text. So here is the activity named result set, and it is exported true. And second is provider. So provider name is credential provider and the authority, and it is exported false. Means we cannot directly access the protected content provider normally, because when you try to access the protected extra content provider or any component, OS provides a denied error. So you cannot access. So with the help of this misconfiguration, we can access the credential protected content provider. So let's have a look. So here is result set activities exported. So let's have a look of result set activity code. So in the result set code, developer implements the get intent instead of new intent. Developer implements get intent instead of new intent, because if get intent is used in the application, as we already discussed, with the help of get intent, we can receive that intent data. Means we can spoof the intent data of that application if in that application intent data is not filtered and get intent is used to handle that intent. So after it, we are simply set the result code and the intent, what we are sending. And after it finishes that activity. So as we already discussed in previous, the set result activity returns to the originating activity. Here, the originating activity is our main application. So let's move to the exploit application code. So let's have a look. So let's practical demonstrate. Okay, so here is the vulnerable application manifest file. In the manifest file, the result set is exported true, and the credential provider, content provider is exported false. So how can we abuse this? So let's have a look to the exploit code. Let's run this first. Okay, so here is our exploit code. So in our exploit code, we are setting the intent, because if the grant URI permission is enabled in that application, so we can write or read the grant URI permission of that application. So simply we are setting the flag grant read URI permission, means we are giving a permission to our exploit application. And after it, we are setting the data URI to pass the content data. Content, and this is the URL of content provider. And we are setting the class name. Which class name? Class name of the result code, result set, in which result set is defined. And after it, we are starting the activity for result and sending the intent and with the request code. So what it happens here? When the exploit application run, it calls all the intent, class name, set data, set flags, and after it start activity for result page. So on starting this, it goes to the so it goes to the result set activity of the vulnerable application. And what we are sending? we are sending the content URI. We are setting some data. We are sending some data to that result set activity. So here the get intent is used. In the get intent, we can pass the get any other intent, because we can spoof the intent. So we are sending the content URI and set result okay, and intent means we are simply setting the activity result code and intent data. So what is here intent data? Intent data is simply this thing. This thing is our intent data. It is set data and it is set flags. So it returns after finishing this activity of the vulnerable application. It returns to our main activity of the exploit application. So we initialize the own activity for result, and we can access the internal content providers data. Let's have a look. Okay, so we are able to access the internal username and password of that application. So where it is stored in the application? Let's have a look. So in the login data.xml file, the vulnerable application is storing the username and password by the content using the content provider, and with the exploit application, we can access the username and password of that file. Like this. So like this, we can also access the internal file by the file provider. So let's move to the next one. So how we secure the application against these attacks? So first one is avoid the use of implicit intent for communication between the component of a single app. And second one, explicitly set the value of Android exported for each component in your event test. And this eliminates the risk of having a components exported if it declares an intent filter. Always validate your inputs carefully and don't assume that incoming intents are well formed. And also the last one, make use of permission when appropriate. If you write a component that you would like to be accessible only to the another application you have written, you can export the component but protect it with a signature permission that allows access only to other application signed by your developer key. So if you have any doubt, please ask. Yeah, please ask your doubt in chat box. No, Gautam, you have to manually find these type of exploits. There is no any tools. So if we got an application, let's say, then we can decompile and decompile the application and analyze the application code, like how it performs. So without code of your application is not work. Yeah, then I already shared the link, the demo applications in the chat box. Please have a look. Guys, if any doubt regarding the webinar of intent attack vectors, yeah, please ask. Okay. So like generally the developer obfuscate the code with the proguard. So in the proguard obfuscation, only references are changed. Like there is no any like string obfuscation. Only the references are changed. You can decompile the application and open with JDGUI and check the references and manually analyze the code. And you can also debug the application code with the use of small I, importing the small I files in Studio. Yeah, I found that that type of intents in pen test. No, Akshay, because browser has limited capability. So we have to use a custom application to exploit this type of attacks. So Akshay, if the code is obfuscated, okay, so you can do one thing alternatively. You can book the intent data. You have the data by the FIDA or objection and analyze the code, like how it is going. So after it, you can also create an expert application. This may be also beneficial. Yeah, any other doubt, guys? Yeah, no problem.
Are there any more questions, guys? I guess, yeah, there's another question.
Okay, what is the working method for SSL bypass to test banking apps? Okay, yeah, Akshay, you can use the public available tools like APK MITM, and you can use the custom FIDA scripts and also publicly available some custom scripts. And also you can create your own custom scripts with the help of FIDA. Okay. How do you demonstrate the exploitation part in the pen test? Since exploitation part would require a malicious app to be urgent and same place. Yeah, right. We have to install the malicious app. Without installation of another app in the test phase, the attack not works.
Let's wait for a minute. If there are no doubts, we will conclude this webinar.
Yeah, okay, sure.
So you have received a compliment from Akshay Deshpande, Amit,
Yeah, thanks.
for your webinar. I guess there are no more doubts. Let's conclude the webinar here. Thank you guys for participating and engaging with this webinar. I hope you had a good time, and thank you so much for attending.